Welcome to your last official day of new work in Algebra 1. After this day, we'll have a couple of days of review of the most important things and skills that you need to take with you to geometry. So don't think you're completely done, but you are very, very close to done. So today's lesson is on writing systems of equations. Our last lesson, we were reviewing how to write equations from words. This is very similar. The only difference is instead of writing a single equation, you'll be writing two equations. So just like that single equation, you'll need two variables, but both variables need to also work for your second equation. So I've got 5 examples here, and I'm gonna start with the first one, and I'll sort of give you tips for how to figure out what your variable should be, and then how to make sure you've used them correctly in both equations. So our very first question right here is, the admission fee at a small fair is $1.50 for children and $4 for adults. $5,050 is collected from the 2,200 people who entered the fair. How many children and how many adults attended the fair? So right here, this last part, this gives you a big clue of what you need for your two variables. So you need to determine how many children attended the fair and how many adults attended the fair. So the answer you're looking for is how many children and how many adults, which tells you those are the two variables you'll be solving for. So for adults, the easiest way to represent that would be A. So I'm going to say A equals the number of adults. And remember, you always need to define your variable in this way so that people understand when they read what you've written, what they stand for. So C will be the number of children. So both A and C need to appear in both of my equations. So the first equation I'm going to write based on this first sentence. The admission fee at a small fair is $1.50 for children and $4 for adults. So I know the $1.50 goes with children. So however many children attended, they would multiply it by $1.50 to get the amount of money for children. So I'm writing 1.50 C. Remember, that's the same thing as saying 1.50 times C. And I also know that they charged $4 for adults. And I know that if I put these two together, it tells me this is how much money they made. So my first equation is just going to be about money. I've got $1.50 for children, $4 for adults, and I know that it's going to total $5,050. And clearly they must be adding the two. So my first equation is right here. Now notice I've used this one, and this number. The only number I haven't used yet is this 2,200 people. So my next equation has to be about that. Since my two variables are just the number of adults and the number of children, when I add that up, it has to equal 2,200. So my next equation is simply however many adults plus however many children equals 2,200 people, because those are the only two options. So this is my system of equations. Notice they both have A and they both have C, and I used every single number in my problem one time only. That's going to be really important. And I figured out what my variables should be based on the question they were asking. Now notice on this one, it very clearly states for each word problem, write a system of equations. You do not have to solve it. So I don't expect you to solve these right now. We're just working on writing them. Example number 2. Alice spent $131 on books. Paperback books cost $15 and hardcover books cost $28. She bought a total of 7 books. How many of each type of book did Alice buy? So the question right here tells me that I'm looking for the number of each type of book she bought. So my variables are going to be the two types of book, paperback and hardcover. So paperback will be this purple and hardcover will be this red. So my first equation, I noticed that 3 of my numbers have dollar signs. All of the dollars are going to go in the same equation. So for the first equation, if it's all about money, I know paperback books cost $15. So I would write that as 15 times P. And I just realized I did something very important right here. I forgot to define my variables. So P, I'm going to write over here, is going to equal the number of paperback books, and H will equal the number of hardcover books. So if I hadn't done that, you might not be able to follow my logic with the equations I was writing. All right, so 15 times P for the number of paperback books. And I know hardcover books cost 28. So I'm going to write 28H. And I know that if I add these up, her total spent was $131. So I've used all of the numbers that have dollar signs. My last number that I need to use is this 7 books. All right, well, I know however many paperbacks she bought plus however many hardcovers she bought has to equal the total number of books she bought, which is 7. So now I've written 2 equations. They have the same variables, so that's my system of equations. Example number 3. During one calendar year, a state trooper issued a total of 375 citations for warnings and speeding tickets. He wrote 37 more warnings than speeding tickets. How many warnings and how many speeding tickets did the state trooper write? So from this last question, I'm going to use this to tell me what my 2 variables are. W will be the number of warnings, and for speeding tickets, I'll use S. Number of speeding tickets. Okay. So let's see. I know that he has a total of 375. So I'm going to write that equation first. However many warnings plus however many speeding tickets equals the total number of citations he issued, which was 375. So I checked off that. Now I notice there's only one other number here. He wrote 37 more warnings than speeding tickets. So that means his number of warnings in total, so W, is going to equal however many speeding tickets he wrote plus 37 more. So notice this one was in kind of a different shape than the others. The others all had 4 numbers. This one only had 2 numbers, but more words. So I had to make sense of the words as best as I could. The next example is kind of similar to the first 2, but with a dash of the third example in there. So we have a group of 36 people attend a ball game. There were twice as many children as adults in the group. How many adults and how many children attended the game? So just like all 3 of these, we're going to use that last question to tell us what our variables are. We have adults and we have children. So C equals the number of children, and A equals the number of adults. Now let's look, we have a group of 36 people. So 36 is our only number that's written out as a number. So that means that however many children plus however many adults altogether totaled 36. I've used the number that's there. There is another number in here, but it's not written out as a number. It's in this sentence. There were twice as many children as adults in the group. So twice as many means to multiply by 2. So if there's twice as many children, then that means the number of children equals 2 times the number of adults. So I'll write 2A. And that's it. That's all the information I have, but it's also all the information I need. If I did want to solve this, I should notice that what I have right here, C plus A equals 36, and C equals 2A, means I could replace the very first C, this one, with 2A, because the number of children equals twice the number of adults. If I replaced that, it would look something like this. Instead of C, I'm going to write 2A. So rewriting it down here, I would have 2A plus A equals 36. Now I can solve this because I have only the same variable, 2A plus A. Well, that's combining like terms. That's 3A. So I now have 3A equals 36. And then I'm just looking for A by itself, so I would divide by 3. A equals 12, because that's 36 divided by 3. And if there were 12 adults, and I know there were 36 people in total, then I just have to subtract out the 12 adults from my total, 36 minus 12, and I end up with 24, which is the number of children. So that's solving a system of equations by substitution, and it's one of the things you'll be working on in Algebra 2. Our last example of the day is slightly different, and you'll see why in just a second. Jenny charges $4 per day to pet sit. Tyler charges $2 up front and then $3 per day to pet sit. They both made $26. How many days did they pet sit? So the way this is different should be evident right here at the end. It only asks how many days did they pet sit. That means I only need one variable, and my one variable is going to be days. So I'm going to say D equals the number of days. That means I must have enough information in here to write two equations that use multiple numbers each. So let's see. All right, Jenny charges $4 per day to pet sit. Tyler charges $2 up front and then $3 per day to pet sit. They both made $26. So this $26 is the one time it's going to be used twice. It'll be used in both equations. So for Jenny, it would be $4 per day. So $4 times D equals a total of $26. So I've used the 4 and I've used the 26 once. For Tyler, he charges an initial $2 and then only $3 per day to pet sit. So I'll write 3 times D. And he also made $26. So in this case, we have only a single variable, but again, it's written in both equations. So your practice is the quizzes. It has, I think, 12 questions on it, and most of them are in the form of these first several, okay? So do your best, and then I will see you soon.